Let's start talking about BGP from this video onwards. But before we talk about BGP, let's take a look at what are some of the terms that are commonly used in the context of BGP. In this segment, we will also look at what are the BGP operations and messages and some of its features and attributes. The focus will not be from protocol perspective, but it'll mostly be in terms of how it is applied in a network environment from an operator's perspective. Now, we know that BGP is the most common inter-domain routing protocol used in the internet. It is a policy-based routing protocol because there are multiple aspects of BGP that enable the requirements of an inter-domain routing protocol. It is a simple protocol from messages perspective, not many messages being types of messages being exchanged, not a lot of complexities there. But then when it comes to configuring BGP on a router to make it behave in a certain way, the configuration is complex. But it also works to the advantage of operators because they are able to get fine-grained control of how information dissemination happens across autonomous systems or across operators. So the references are these listed here. We will be referring to BGP4, and next version of BGP is MPBGP, multi-protocol extensions for BGP. BGP4 enables IPv4 exchanges, whereas MPBGP enables IPv6 exchanges. Now, so to start, let's take a look at some of the terms that are used in BGP. Now, BGP session is pairing that is established between two BGP routers, two routers that speak BGP. When we say two routers that speak BGP, we can also refer to them as BGP speakers. That means any router on which BGP runs could be a BGP speaker. If we pair two speakers to be exchanging BGP attributes, BGP update messages, then they are said to be in a BGP session, and the two endpoints are said to be BGP peers. So if we have a BGP session established between two BGP speakers, then those two become BGP peers. The two types of BGP are eBGP, external BGP, and internal BGP. We will see what the differences are in detail in a later video segment, but for now we will just take a look at what it means in this particular context of the diagram that is displayed here. The prefix are the IP addresses, the network information that is exchanged between the two BGP peers. There is a set of BGP attributes that describes the information that is exchanged between two BGP peers. And route is a set of prefix plus the corresponding attributes. So it's not just the prefix, but the attributes that corresponds to the prefix also, both together is referred to as a route that is exchanged between two BGP peers. Now let's take a look at this particular network example here. We have three AS here, AS1, AS2, and AS3, and we have a set of routers within each of these AS. AS3 would send AS1 the list of prefixes that are reachable from AS3. So if there is a set of networks that are reachable from AS3, that networks are advertised by 3A to 1C in AS1. And AS1 sends AS3 the list of prefixes that are reachable from AS1. So any networks that are reachable from AS1 is exchanged from 1C to 3A. Now, similarly, AS1 sends the list of prefixes or the prefix reachability information through the gateway router, which is 1B, to A, which is a gateway router for AS2, and similarly the other way also. So now, this particular AS, where 3A, 3B, and 3C are configured together to be in the same autonomous system, they're all BGP peers themselves to each other. So they are running what are called iBGP. Similarly, within AS1, 1A, 1B, 1C, and 1C together form iBGP peers. Similarly, 2A, 2B, 2C form iBGP peers in AS2. Now, the gateway routers here, 3A, 1C, and 2A, one from each AS. It need not necessarily be one from each AS, but in this particular case, it's one from each AS. They are called gateway routers. They behave as gateway routers that exchange information that represent one AS. So 3A is the AS3 representative to the rest of the world. 1C is the representative of AS1 to the rest of the world, and so on. There is a BGP session between 3A and 1C and 1B and 2A also. And those BGP sessions are called eBGP session because they are between two routers or two AS that are different from each other. So in this, when eBGP peers exchange prefix reachability information across, then that is how the different AS learns the routes or learns prefixes that are reachable through other AS. So when a gateway router receives eBGP learned prefixes, the gateway router uses its iBGP session to distribute the prefixes to other routers in the AS, which means that if 1C receives an information from 3A with respect to what are the kind of networks that are reachable from AS3, then 1C propagates information to 1A, 1D, and 1B. And that is how all these routers also learn this information. They are not connected to 3A directly, right? So all routers in this manner learn about the prefixes that are reachable through AS3 in AS1, and all routers in AS1 learn about the prefixes that are reachable through AS2. So this is how the entire information spreads across in the network. So these are the terms that are used: BGP session, BGP peer, eBGP, iBGP, BGP prefix, attributes, and a route. Now, how does this information dissemination happen? Just like any protocol, BGP4 also defines a set of messages for these particular message exchanges. So the first thing to happen is the BGP session gets established on TCP port 179 of each router. And then once the session is established, they exchange active routes. And then if any incremental route updates are there, if any change in the paths are there, then that gets updated to the peers. And this process continues until the session gets torn down or one of the routers goes away. So the kind of messages that are exchanged are open. One is the open message, which is to establish a peering session. The second one is a keep alive message, which is handshaking at regular intervals just to ensure that the other end of the peering session is up and running. A notification session is to shut down a peering session, either because we disable BGP on a router or for some other reason. And the other major message is the update message, which announces routing updates or which withdraws routing updates. So if there is a new route coming in, then it is announced through update message. If there is any route that is not valid anymore, that is also advertised as a withdrawn route through an update message. The set of attributes that are related to any routing update are also passed on through the update message. We mentioned BGP attributes. So all these attributes are passed on to the BGP peers through the update message. We will look at the format of an update message through a sample Wireshark capture. But for now, let's just understand that it is the update message that carry any changes to the routing updates or any changes to the attributes. Now here is a format of an open message. It's pretty simple. The type is open. Version is 4, BGP4. What is my AS number? 30. So in the BGP configuration, we have to configure what the router's AS number is and the BGP identifier is. And then we also mention a set of optional parameters. One major one is capability. So each BGP speaker has a set of capabilities. And during the open message, the set of capabilities get exchanged, negotiated. And whatever is acceptable to both peers in a session, that is what eventually becomes the capability of that particular session. So here we have one capability as multi-protocol extensions capability, another capability as route refresh capability. These stand for certain things. Now, between two BGP speakers, if one of it does not have MP extensions capability, then the session will degrade itself to a version where there is no MP extension capability because the other end does not support it. But if both ends of the session support MP extensions capability, then we have a BGP session wherein we can exchange IPv6 routes. Similar thing for route refresh capabilities and any other capability that will come across. This is done during the session creation time or during the exchange of open messages. Now, the other message is a notification message, which is used to end a BGP session. For example, in this particular Wireshark capture that's there, one BGP speaker has sent an open message to the other one. However, the other BGP speaker has not liked the open message for some reason. So it is sending a notification message saying open message error, and it's a bad peer AS. So it is tearing down a session with a BGP speaker. Now, there are other types of messages. The update message feature we'll see later. Now, as far as features of BGP are concerned, we know that BGP advertises to neighbors only those routes that it uses. There is no need for periodic refresh. The routes are valid till it is withdrawn. Withdrawn in the sense the update message will show whether the route is withdrawn or the connection is lost or the session gets torn down. Incremental updates are possible. BGP provides the capability for enforcing policies. It enforces policies by choosing paths from multiple alternatives and controlling advertisements to other AS. Now, this is one thing that we will see in the subsequent videos, how it is that we can configure BGP to prefer certain paths over the others and prefer to advertise certain paths to its peers and not advertise all the paths. In terms of policies, again, there are two types of policies. One is an import policy and one is an export policy. Import policy has got to do with what kind of routes will I take in or will I accept among the routes that are advertised or given to me by my neighbors. What are the kind of routes that I'll accept and what do I do with them? In terms of export policy, among all the routes that I have, what are the kind of routes that I'll announce to neighbors and with what parameters. And that depends on the relationship with my neighbors. If I don't like an autonomous system who's not in my favorites list, then I'll not probably advertise a good route to him. I can deprioritize the good routes and say that, advertise that, okay, I have lesser routes, and the other AS will not know that, and we'll be using our autonomous system as a transit AS. Now, how does the BGP routing process happen at a higher level? We have routes coming in from the BGP speakers. There is an input policy engine. So the implementation of a BGP routing system may not necessarily use the term input policy engine, but there'll be something that does the functionality of an input policy, which means that all the routes that we are getting, a set of input policies will be applied on the routes that are advertised by our neighbors. And then we make a certain decision. We go through a certain decision process in terms of what routes we will accept. And those routes are then put into the IP route table. So the route table will have one route that is the best, or not necessarily the best, that will be the output of the input policy engine and the decision process, which will be used for actual packet forwarding. And then to advertise to other neighbors, we will pass these IP route table through a set of output policies or outbound policies. And then those routes will be what are advertised to the neighbors. So we have an adjacency routing information base in, we have a local routing information base, and we have an adjacency routing information base out, which are the offshoot of applying the input policy, our own decision process, and the output policy mechanisms to the routes that we receive from a neighbor. Now, we mentioned BGP attributes. Some of the BGP attributes that are commonly used are origin, AS path, local preference, next hop, and multi-exit discriminator. These are attributes that describe a route. Okay, what are the other properties of the route that are relevant to the other BGP speakers so that the path can be used in the appropriate manner? We will look at these attributes in detail in the next video, but just to give a flavor, each route or each prefix is accompanied by a set of attributes which make up the entire route in the update message for a BGP. So in summary, what we have seen so far is we've briefly looked at what are the terms used in BGP, what is the BGP operation mechanism and the types of messages that are used by the protocol, what are some of the features of BGP at a very high level, though in the subsequent video segments we will see how these features are actually configured and how BGP responds to these features. And we looked at some of the attributes. Now, if we look at the protocol, look at the RFC, some of these attributes are well-known attributes, discretionary attributes, transitive attributes, and optional attributes. This classification is depending on whether these attributes must mandatorily be inside an update message, or it could be optional, or whether these attributes get carried over from one peer to another till the end of the routing line, or is it just an exchange between two ends of a BGP session? So depending on that, there are different types of attributes, and we briefly looked at the names of some attributes. In the next segment, we will look at these attributes in a little more detail.